Hello everyone. Today we are finally doing the last problem. I actually checked the easier ones. They didn't seem easy to me at all. And I think this word container was easy for me yesterday. At least easier than some of the other things because here the solution was pretty straightforward. Let's see, maximize unique characters. Okay, everything is as usual. We are having word list, checks compatibility between them. Build a word selection system that left some bugs in the finished work. Max Unique Solver class should find a subset of words that maximizes total unique characters with no character used more than once across all selected words. Okay. Explore the code. Press the green run button, use the drop down. Okay, fix the bugs. Word list, as usual, has bugs. And solve what this should be, make the test pass. To find the word subset that maximizes unique characters. The words can both be selected only if they share no characters. Uncomment test wordle words and test large words in the solver test to make them pass. Okay, let's now see. So let's first run main just to see. Alphabet is this. Words are this. Invalid words I think are the same. So we are probably removing some invalid words. Selected unique characters. Okay, we are not selecting anything. That's reasonable. Let's check test word list. So filters duplicates. Let's actually run those. Yeah, all of those are passing. So we will soon be checking what word list class does, but right now we see that these are the characters. This is the alphabet. Valid words. Okay, so only 3 words are valid, and that's because I'm assuming, yeah, we have twice this letter B, so it's invalid. Interesting. I'm not sure what happens if we have something like this. Let's actually test this. Oh yeah, it passes. So we can have 2 B letters instead of 1, as long as this is possible in our alphabet. Let's actually check in the end when we are testing solver. Alphabet, what's the alphabet? Alphabet, get small words, get months, get primes, get wordle words, get large words. Okay, let's see. Small words. Interesting. So we are creating alphabet automatically. Filters, valid words, compatible disjoint words, incompatible, many shared. Okay, let's actually look at the word list now. So it gets words and it gets alphabet. How is this test solver implemented? Get wordle words and from words. Let's see, alphabet letters. Okay. Fine. So we always have unique letters. We don't need to worry about this complicated stuff where we can have duplicate B here. Fine. So what we are doing, we are just creating the words in the alphabet, and then self-build is the final thing that we are running. So word and words, if self is an alphabet, Okay, so all characters are an alphabet, and all characters in the words have to be unique. Okay, character. We have all characters for the word in this set. Fine. Has unique characters seen as set for I in range. Why do we start with one? I think this is one of the bugs. So we need to check all letters in the word. If word I in seen add word I. Okay. Then valid words. We return list of self-valid, which is fine. Okay. These are all the unique characters, and all characters are in the alphabet. So then are compatible. Chars A self-char sets. Okay. Shared, return shared. Yeah, so we are just returning that there are no shared characters. This is possible to optimize with bitmap. Yeah, here we just need to add another function, because then those words being compatible will be very easy and quick to check if it will be of 1 instead of n. Okay, char set. Total unique. Yes, this looks correct. Total unique characters. For words. Okay, this is basically calculating the length. Okay, and alphabet returning self. Set self alphabet. Okay. Fine. Let's now run the test word list again. And let's now go and fix the tests there. Test word list. So incompatible with many shared test char set. So, okay. Test total unique characters. Total unique characters with ABCDFS6. Test alphabet. Word list alphabet. Then let's remove those two tests, uncomment those two tests and see that they're failing. They're failing unequivocally. Test valid words, first character repeat, so length of valid words. There will be just 3 valid words here. Oh, this is also invalid word because it has duplicated characters. So only this word. Yeah, we need to first remove those words with duplicated characters, and then it will be ABC. Yes, it's there, and PQR is also there. Yes, it should be 2. Test compatible single shared character. So ABC and CD should be incompatible. False. Okay. Oh, I'm guessing I missed this part in word list is compatible. Oh, obviously it should be smaller than 1. Yeah, okay, now we have fixed that. Now let's implement the solver. So solve the word list. We will be implementing 2 functions. Solve simple self return. Let's have it as a private method. Solve simple. So what does it mean for us to solve simple? We need to find the subset of varied words that maximizes total unique characters. How do we go about this? It's kind of like DFS. What do we need to return? We need to return a list of strings. So let's implement implement a DFS algorithm with backtracking. It should for solve simple method. It should keep track of the currently added words and try adding new words, new compatible words, starting at the next one, at the not considered ones. So, okay, we need to do that. Implement DFS algorithm, use only public methods from word list. Let's see if it succeeds. Okay. I will copy just to look at, so that it's easier for me to look at the code. Okay, so simple valid words, self-word list valid words. Okay, best solution, best score, DFS current words. No, it's not implementing things correctly. Because I think it will be mutating current words in each try and passing those. Why do we even want to pass those? Okay, maybe it current words. Okay, it's copying those words every time. No, let's not do this. Okay, let's just do current words as a list here. And current score total unique characters. If current score better than best score equals current score, best solution, current words, copy. Okay, that makes sense. Then for I in range, start index, okay. I'm thinking about how to solve this with bitmap. It's solvable with bitmap quite definitely. But for now, if current word in current words, okay, it backtrack also works. Okay, fine. So actually both options are fine. I just like mutating things outside instead of the inside. And then current words, and we start at position 0. Okay. If compatible is true. Yes, it looks like something that should work. Test word list. Oh, we want to test solver now. Okay, so probably all tests. Use chars for word and result, a certain word valid. Okay. Okay, so let's also just we are just validating this everything. So let's run this part. Oh. Okay, well, that's clear. I changed the implementation and forgot to change how we call it. So DFS at 0 position is what we are starting. Where do we give? Oh yeah, DFS is also called here. Okay, we are passing all the tests. Now we need to optimize the solution. Let's optimize it. If actually adjust return with bit mask. So let's now define this method. So with bit mask, and it will be just same self and outputting a list of strings. And it will be pretty similar to this code, but what will change? First of all, we will have current state, which will be 0. We just want to make all of those operations much faster. So current state, we don't want to compare this word to the list, we just want to compare for current word. No. Is compatible will be equal to word bit map is self word list get bitmap for word is compatible equals current state and word bitmap equals 0. If is compatible, then we do current words append word, but that's not the only thing that we do. We also do that current state equals current state and word bitmap, and then here we do current state XOR word bitmap, I think. So all the ones, all the zeros that we marked as ones here, we now want to mark as zeros back. So yeah, we have iterated over everything here. And now the only thing that we need is to implement this actually get me bitmap of word. So for word list, self and word, which is a string, and it returns an integer. So return self bitmaps word. Okay. So just to check, all of them, yeah, are lowercase, and it can be numbers, letters, but this is all fine, I think. Okay, let's do this. So we can only have these two alphabets. Yeah, under this assumption, let's create the word list. So for self alphabet mapping equals character index for index character in enumerate self alphabet. Okay, so here we will now be selecting like the offset for each of the things in our alphabet. And now here, char sets, and here we will do def generate bitmap self word, which is a string, turns an integer, and answer equals 0. For character in word, answer equal 1 moved by self alphabet mapping of character, return answer. Okay, so we are now returning all this. We have not changed anything else. Yeah, now this is the final thing. Self word self bitmaps. Bitmaps equals, okay, what will it be? It will be dict pointing strings to integers. That will start as an empty one. Int self bitmaps word will be self generate bitmap for word. Let's see. And local variable, okay, reference before assignment is compatible. Is it because of non-local issue? Non-local, best solution, best score, current state. Oh yeah. No, actually. So we have one correct implementation. Test word list. Let's see. Write tests for bitmap implementation in word list. Let's see what it has generated for us. So word list, alphabet ABC. So yeah, this should be 1, 2, C. Will this be 4? Oh, B2C, yeah, so it will be 4, correct. So now AB should have bits and, okay, so it will be 3, 5, 6, right? Alphabet ABC, so ABC equals 7, fine. And should AB and C should not be compatible. Okay, test bitmap larger alphabet. Hello world. So yeah, maps should not be 0, they can be shareable. Test bitmap empty intersection. So A, B, C, D, E, F. Well, this is kind of the same thing that has Hello World, but fine. Bitmap alphabet order independence. Okay, this should also be fine. Let's check test word list. Actually, we are iterating over set, so this, when we are assigning bitmaps, so this is irrelevant test. We don't need this functionality. Now, test bitmap larger alphabet. How can it be missing? Oh, it's missing because it's an invalid word. So this is an incorrect test. We shouldn't actually have hello. So since this and the next test are pretty similar, let's just remove this test. Okay, this works. So now let's run solver again. Stored state equals current state, and here print stored state current state. This is my main hypothesis. Yep. So we should be what should be the right bit operation to get the current state to its previous state instead of this. Oh, yeah, this was stupid. This is OR. And then yeah, actually makes a lot of sense. Let's test solver. Pass all the tests. Let's test optimization. Test solver. Timeout, exceeded time limit. Let's see. Okay, this passed. So only this thing is not passing now. Get large words. Okay, so here the problem is that there is another problem. That the space is too big, and if we are repeatedly visiting the same space, can it be the case? So the only thing that I can think of is that we can memorize things. So it would be, oh, from partial, right? From partial import LRU cache. I don't remember where I should be importing this. And DFS here, it will be add LRU cache. But we will also need to pass current state. So current state will be passed here, and we will also need to pass current state here. Yeah, no model name partial. Let me see what's the chat message. Hey bro, what are you doing? I'm solving an AI assisted coding problem, which is, it would be hard to describe it now. I think you can go to the beginning of the stream. It will give you a better idea. But currently I have almost finished everything. I just need to figure out a more efficient approach here. Yeah, still the state space is too big. Yeah, we also cannot store current index here. Let's actually change this back, and I will optimize it separately. So with bitmask, dev solve with bitmask efficient. So okay, let me see. What my idea would be to add LRU cache, and here to only pass the current state and iterate over all words. Can we prune the words that we are iterating over? I'm not sure. Let me see. So how to make this function work for hundreds of words? Pruning. If we can't possibly beat the best score, stop. Doesn't look like correct implementation. We are counting in some bits. Okay, calculate current score bit We also have word bitmaps. We already pre-computed all of word bitmaps. This doesn't improve the speed. Calculate current score using bit counting instead of string operations. Current score. Oh yeah, okay. Total unique card. Yeah, that's something that I have missed. Obviously, that should improve the solution quite a bit. So let's put it here. So we are now solving with bitmask efficient. Test solver. Well, okay, let's remove the LRU cache altogether. Still not passing, but let's see what else. Output, yeah, execution exceeded time limit. Update best solution if current score is better. Try adding each remaining word. Best score is just the length of characters. This is stupid. I don't see how it can work. But let me just check. Maybe it's me who's being stupid and misunderstanding the code or something. So yeah, it can never be that big. So I think we need to do some additional stuff here, like memorization. Yeah, that's another thing that I thought about for pruning the words, starting with the bigger ones. What about memorization? Sean, can you implement it? Use LRU cache and iterate over all words. So stop passing start index and instead pass the current state in dfx. So it should be if we have many ways to combine different words to get the specific combination of letters, then it can become faster. Let's see what it has generated for us. Okay, so with bitmask efficient. Func tools import LRU cache. Okay. Functools import LRU cache, valid words. Functools import partial. That's why I remembered partial also. Valid words, self word list of valid words, word bitmaps. Okay, LRU max current state. If current state and word new state. Okay, it looks good. Type object is not subscriptable. Let's just remove that. I think that's the issue that we're facing. Okay. Let's now add this optimization. Maybe it will solve our problem. So one of the issues is that we are iterating over all words. But we need to check whether the word, we're just doing the check very fast. Okay, let's see. Word data. Let's also start by using the longer words first. Yeah, exceed time limit. Well, I tried most of the things that came to mind. Let's actually also remove the final test just to see that this solver is actually working correctly. Test solver. Yep. So all of our solvers, and let's ensure that we are using. Yeah, solve bitmask efficient. So we have implemented 3 different solutions. I think this is the most efficient one, but still doesn't tell us much on which, like, I couldn't figure out the solution that actually is fast enough. Maybe that's just a Python problem, and with other with our languages it's fast enough. I don't know. Okay, let me see what's the chat. How can I shift to Python for AI advancement? Yeah, I was busy. Sorry that I wasn't answering some of the questions. And probably the person who wanted to know how to transition to AI advancement already left. How can I shift to Python? This is such a strange question. Like, start writing in Python? Whatever you're doing, try Python there. Start doing pet projects with Python. Try to use a project in your work that is built in Python. What can be a better idea here? I'm not sure. What are people waiting to hear, expecting to hear? Thanks everyone who